Guys, welcome back to Vlogs with Sanjira, and today without any delay we are going to learn about Smith chart, how to plot the Smith chart. So basically everyone has this doubt as to how to plot the Smith chart when the question is given, how to understand it, where to find which plot and all. So basically today I'm going to explain about it. See, read the question. A load of 100 and plus J 150 ohms is connected to a 75 ohms lossless line. Find tau S lead admittance Zn at 0.4 from load locations of Vmax and Vmin with respect to the load if line 0.6 lambda long, then F is Zn at generator. Okay, so first, whenever they give your Smith chart question, always divide your Zi by Z0. You have to find load impedance, right? So we have 100 plus J150 omega, right? That we have to divide with lossless lines ohms. So it will be 100 plus J150 by 75, which we got it as 1.33 plus 2J. So how to plot this 1.33 plus 2J? See, here is our Smith chart, right? Okay, the point is here, 1.33 plus 2J. How does 1.33 plus 2J come? That is the question. See, when you see from here, if you want this point, I will go from here. From here, I'll mark 1.33. From here, I'll mark 2G. Let me highlight it. Give me 2 minutes. So I'm going to highlight it so that you understand it well. This is your 2J's line. All these things is your imaginary axis, and all these things will be your real axis. So imaginary axis 2J is done. Why is it plus 2J? Above parts is plus and below parts is minus. Now I'll show you how did this 1.33 come. Trace this back and you'll find your 1.33. See, when you trace it like this, it is between 1.2 and 1.4, which is 1.33, and this is exactly at 2. This is how you find 1.33 plus 2J. As soon as you find this, take radius from O and to the point which you have found and draw a circle. This should be a step 2. Step 1 is dividing those, finding this value, plotting it on Smith chart. After this, immediately you have to draw a circle keeping this point P as your radius. After this, extend the line from the origin to on the line of P, you extend it to Q. This Q will be your point wherein you'll use it in next derivations. How to find this Q is, chuck this the outermost line. This is 0.19 and this is 0.20. In between we have 5 divisions. In between we have 5 divisions. So our point is here. So it is 0.19, 0.192 and 0.194. So this is 0.194 lambda. Angle is 40 degree. Here you can see here is your angle. This is your angle. Angle is 40 degree. You have to mark this and keep. As soon as you do this, extend the same line in negative direction. When you extend the same line in negative direction, here you will get a point. How to find this point? I'll show you. This will be your admittance. How is this admittance? Admittance is always opposite to impedance. So impedance is this side. Impedance is this side and your admittance will be this side. So this is your admittance. How to find admittance? I have the point here. Trace it back. I have traced this. Now I have to trace it like this, right? Along your real part. So I'm going to trace it. So this one, when I trace this side, I'm getting it as C. This is 0.3, right? And this is somewhere around here. Here I'm getting it as this point. So our real point will be, this is 0.2, this is 0.22, 0.24, 0.26. I'm getting it as 0.26. And this is 0.35, 0.226 or 2 to 8, and your j is this side, right? See, it is 0.3, 0.32, 0.34, exactly 0.35. So this is the value of your admittance. As soon as you get admittance, you have one more thing to do in Smith chart. What is that? See, this is the admittance you have found, right? 0.22 minus 0.305. This one you have to divide it with your impedance so that you get your actual admittance. You have to divide it. Next, what they have said us to find is D question, Zn at 0.4 lambda from the load. So this is the load that we have considered, 0.194. From here they are saying 0.4 lambda. So what you have to do, 0.194 you have to add it with 0.4 lambda so that you get 0.594 lambda. And the most important thing to remember in Smith chart is this whole circle is 0.5 lambda. The whole circle of the Smith chart is 0.5 lambda. So till here, you know that 0 and the whole circle will coincide at a point. So this point is 0 as well as 0.5 lambda, right? So 0.5 lambda is found now. What is remaining here? 0.5 lambda is gone, 0.194 lambda is there. So that 0.194 lambda, you have to plot it in Smith chart. So, one second. I'm really sorry, it is not 0.194 lambda, 0.594. If you subtract, you will get it as 0.094. So 0.094 lambda, you have to plot it in the graph. So this is my 0.094. How did I get it? 0.09 is here, 0.092 and 0.094. This is my 0.094 lambda. Now from the origin, draw a line for it. 0.0. After drawing the line, here you find the coordinates. How to find the coordinates? Again, same real and imaginary part you will have to mark. Okay. See, I am going to mark it. This point I'm going to mark backwards so that you understand from where I'm getting this point. My real axis is done. Now let me go to imaginary axis. Okay, so this is done. After this, you check it out. This is going towards my 0.3. And my imaginary axis is going towards 0.6 to 0.7. This is 0.05. So, sorry, this is 0.6. This is 0.65. So this will be 0.63. That is what I've written. 0.3 plus j 0.63. That is what is given here, 0.63 plus 0.3. But to find Zi, you have to multiply it with ZL. So I have multiplied 75 into 0.3 plus 0.63. This is done. How to find Vmax from the load is, what is Vmax from the load and Vmin from the load? Let us see. Vmax is 1 by 4 lambda plus whatever you have got. So, see. 1 by 4 lambda is what? 1 by 4 lambda is nothing but 0.25 lambda. So, Vmax from the load is 0.25 lambda minus whatever you have got. Vmin from the load is 0.056. How did I get this 0.056? Let me explain. This 0.056, we get it when we find Vmax from the load. When you add Vmax plus 0.25 lambda, you get Vmin. This is the solution of the question given. This is the Smith chart, and hope you understood how to find this real and imaginary axis parts and how to find your standing wave ratio. Yeah, standing wave ratio, you can find it either by here. See here, standing wave ratio is 5. One second, let me focus it. This is 4 and this is 5. Standing wave ratio is 5, or you can draw a straight line from here and 5 and find here. This will be 5 again. You can either draw a straight line or you can just find a point here and find it off. That's it, guys. That's it. Thanks a lot for watching. Hope you understood. Comment down if you want more such videos. Bye bye.